Oh yeah, probably do this too. And we're back. And we're back. There we go. And we're back. And it's COMP392, and it's week 5, lesson 5, part 3. And the question I just asked was, are you someone who doesn't like TypeScript? And there might be people out there, and I understand why, by the way. You don't have to use TypeScript in the stuff we do. Remember, I'm not going to make you use it necessarily on your exam. If I get you to do an exam for midterm, I won't make you use TypeScript. It won't be required. But I'm showing you the tools around TypeScript, you know, to make it easier for you to build enterprise-level applications. Modules and that kind of thing, for most people, are easier when you create namespaces and modules with TypeScript than when you don't. All right. Some people find they can do it anyway. And you can use other methods like the require.js. Require.js will allow you to, create modules and all that kind of stuff without the use of TypeScript, right? But I find that for the most part, one of the most accepted ways of building larger scale applications these days is using some kind of pre-processing language like TypeScript or CoffeeScript or something like that. CoffeeScript is, of course, becoming less and less popular. JSX is kind of on the rise. That's another one that's kind of coming up. And of course, eventually we're going to be using ES6, right? ECMAScript 6, which is going to be more available to us across across different browsers. So let's talk about TypeScript really quickly before we get in. I want to show you a trick. A pain in the ass for me, if I go to Learn here, okay, if I go to Learn and Play, a pain in the ass for me is always something like this, right? So if I go to my person class, let's go back to this example, right? So I have my class. I say my class is called person. Here's my class person, right? And as I start typing, notice that my class person creates this closure, this self-executing anonymous closure that has an alias, person. That's what it is, right? So this would be your pure JavaScript for people who are liking this JavaScript stuff, right? In my constructor function, if I have a constructor function, if I say constructor, normally what we want to do with the constructor function, we can use it for initialization, right? A lot of times we can force the user, to pass parameters into the constructor in order for us to initialize some important variables that are part of the members of the class. So normally you might see me doing something like this: private instance variables, and I do this all the time, right? And then I might have something like this: private, and then I have a name like something like name, right? And then I mention what it is, string, right? Now notice on the JavaScript there's nothing, right? The only time it becomes prevalent what this is if I go something like this: private name is here, right, as an example. And then in the constructor, I say something like this: this._name is equal to name, right? You might see something like that. And this is a very common pattern that you see all the time. All right, and then maybe I have some kind of public method that, let's say, for example, say hello. You've seen this before. And in my say hello, it's returning void. It's not returning anything here. That's my public method that I'm writing in my class person, as an example. And I want to create a way of kind of combining this. I use console.log, and I do something like this. I say, well, this._name, right, as an example, whatever the person's name is, and then says hello, right? That's just something that we've seen a lot of times. So this is cool. So this is what you get. Oops, this is what you get on the side here. Right, so you go this.name is equal to name, and notice that I get a bit of duplication, right? No, let's get rid of this for a second. I don't know how that went into the constructor, but let's just look at this for a second. What it normally looks like is this. Take a look, right? This.name is equal to name, right? But what if I could declare this? And this is what a question the people at TypeScript and ECMAScript 6 came up with. They said, hey, we do this all the time. I have a private member variable, and I want to initialize it right away, and I put it in the constructor. Right? What if I put it in the constructor and use the access keyword, it does those two steps for me in one step. And that's what they've done in TypeScript. So if I want to do one of these, let's say I take this and I cut it out of here and I put it inside my constructor like this, right? And take this away, right? Then I can get rid of this little thing here so the thing. I don't have to have a private instance variable section, and the result in JavaScript is the same. And guys and girls, you might say this is weird, right? But I can do private and public parameters that go into the constructor function, and they do that same thing. This name is equal to name, right? Just like it shows you here, right? And we have, in this particular case, the way JavaScript writes it is you have a local variable called underscore name, and you're just basically saying this name is equal to name. So I can leave my constructor function free of those auto assignments, the assignments where I initialize. All my initialization doesn't have to happen here. So it gives you another little bit of flexibility when you want to write stuff in JavaScript. One line, again, this is another reason why I use TypeScript, is I can do things quicker by using TypeScript than I would be able to do with JavaScript, and I'm less error prone in general, right? I can commit less errors. The thing about using pure JavaScript, again, is it fails silently for the most part, right? Unless you put on strict. Even if I put on strict here, so if I go in, and I can do this with TypeScript, I can say use strict. It's not going to hurt me to do it. It's not going to help me because JavaScript or TypeScript is kind of using strict, right? I can still do this, use strict stuff, no problem. But I wanted to point this out to you as I code today. So when you see it, you're like, hey, what is he doing? That's not right, right? It's okay, it's a shortcut, right? So this is one of the shortcuts that's, again, it's a candidate for entry into ES6, and you're going to see this stuff, or ES7. As we move towards the next version of JavaScript, you might see it possible. The other thing that you can also see is things like lambda functions, right? A lot of times if I have an anonymous function, as an example, like this one, see this anonymous function, if I was to write this code here, I'm just going to copy this code for a second. Because remember, TypeScript is JavaScript. You can use JavaScript exactly in TypeScript, and it can give you code hinting. So if I was to copy this side and go in here and just paste it, right? So paste. It's okay, right? It's not going to give you an error to do this. You can do this in TypeScript, and it'll produce this in JavaScript. It's just JavaScript. So you can accept JavaScript in there, right? But what if I want to do this? Right? And notice that there's an anonymous function here. Well, remember, anonymous functions can use something called fat arrow functions instead. And I've shown you this before. I just want to point this out here. So if I take this function call away, right, and just use brackets, there is a quick way of doing this using a fat arrow function like this. And this is the new ES6 way. You might see ES6 producing something like this for you all the time. So this structure here is equivalent to this structure over here. There's no difference. I'm going to have to send the goon squad after those people. All right. So that's the thing I want to show you. I want to show you that there's no difference between this notation and this notation. And you're going to see this notation here a lot more in JavaScript, ES6, right, then you'll see this notation. You're moving away from this anonymous function. So this is called a lambda expression, right? And it's, or a fat arrow expression as well, it's called that. And what we can do with this, it gives us a little bit more flexibility in terms of the way we name functions. Same thing with so this is a name function. This function person is a name function, which is the constructor function. That's why it looks in JavaScript. And notice how I have person prototype say hello, and is again this anonymous function. Again, I can take this away, and I can write this prototype like this with JavaScript as well, or TypeScript. I can do that, right? So the arrow function says basically, when you see these two brackets, it says execute the following. That's what it really points to. So it's kind of, they're trying to make it simpler. So instead of putting a function within a function, they're saying, and especially anonymous functions, they're saying, whatever you see these arrow or these brackets, these parentheses with an arrow function, it says, whatever comes after the arrow, execute. When you, and that's attached to this function here, right? So again, you're going to see JavaScript change to this kind of notation. And one of the things that's already happened, if you look at Node.js, if I go to nodejs.org, right? And for those people who are doing COMP392, right? I know those people in the room doing COMP392. And if I go to some examples for getting started, so if I go to docs, right? And if I want to look at some getting started guys, like if I go to about, look what you see here. This is right on the Node.js website, right? You see a couple of things, new keywords, const, right? And you also see fat arrow functions right here exist because these are part of ECMAScript 6, the latest version. So you see that TypeScript is evolving to try and match up to what we have. That's the new language that's coming out, the latest version of JavaScript. So once you see this fat arrow function, just consider it saying, you know, put a function. If you put a function between the request response over here, right? It's like doing that and take away this fat arrow function. So it's an anonymous function, but really the way you should read it is make an HTTP server, right, with a request response parameter being passed to it and execute the following. That's what I want you to see it as. Okay, so whenever you see a fat arrow function, it means execute the following. Okay, and I'm going to do that today in my code. I'm going to start using my fat arrow functions instead of anonymous functions as callbacks. All right. So if you see me doing it, please don't say, "Hey, what is he doing?" Right? It's because we're moving towards a new standard. The other one is this example of a backtick in ECMAScript 6. ECMAScript 6 allows you to do this backtick. All right. Here's the backtick, and take a look what this format is. It says, "Hey, I have this." And by the way, the backtick, where does it exist in your keyboard? If I want to do a backtick. That's a new thing.
Besides one.
Besides that?
Besides one.
Besides the one or underneath the tilde, right? If you look at the tilde sign, that's the new backtick that's being used in JavaScript, right? So if you do backtick, you can actually do almost like, you know, passing in a value. If I use this $ and the name of the variable here, what this is saying is, I'm going to take the variable, right, and inject it into this string. That's what I'm doing here. Okay, I'll do the same thing here. So this is backtick notation, right, that we used, and what we're doing here, right, is we're injecting that code. And we do that a lot with. We can do that with other languages with %s. Remember that's kind of formatting, %s, %c. We're moving away from that in JavaScript instead of using percentages to format a string, and we're using this backtick notation that you see here. This is acceptable, again, in ECMAScript 6, backtick notation, right? Okay, so just mentioning it to you guys so you see it. So it's not, you don't see it's really odd and unusual, and it doesn't look ugly to you. It's new. Okay, let's take a look at this next piece, right? So backtick notation. So how would I do that? If I was going to code it, what does it translate into? I'm just going to undo here. And the great thing about the playground is it allows me to go back to this, right? Instead of using this, if I wanted to use backtick notation, right? So to say hello, it would look like this, right? So I'm going to go backtick, right? Notice how it becomes backtick notation here. I'm just going to erase this. There's my two backticks, right? And I'm going to say $ and the name of the variable. So this dot underscore name. That's the name of the variable, right? That's the backtick notation, and then space says hello, right? How does this translate? Well, depending on the compiler, in this particular case, on the playground, it doesn't understand what a backtick is, right? But this methodology, you're going to see more and more. It's going to be part of the way we do things. Let me go back to thing to see. Is there anything else I missed here? Right? No. It's just the $ open bracket. That's the format. And inside that, you're going to have this. Once it sees $ open bracket, it's going to know what to do with the backtick. But unfortunately, in the playground, you don't see that. It kind of interpolates this, which is bad. So what I'm talking about is code interpolation, where you actually get data and it interpolates, or it gets injected into the string. All right. So you'll see backticks a lot. Okay. Let's get to Blender for a second. I want to take a look at Blender to understand how to do child objects, which is really the topic of this section of what we're going to be doing this week. So I'm going to go back to Blender. I'm going to open this up just for demonstration purposes. And remember, I'm going to just kill this block here, this cube. by pressing the X button. I want to pull up my little handy dandy keyboard wherever I have it. All right, and what I want you to do while I'm getting ready is I want you to create a sphere, because remember we're talking about a sun and stuff like that, right? I want you to create a sphere, and in the sphere, right, I want you to create another child's object, which is also a sphere. All right, how do we do that in Blender, right? So first I want to create a sphere. How do I do that? What are the shortcuts again in Blender? One day I may test you on this. Shift A. So I'm going to Shift A. I got to focus my mouse in the middle. Shift A. I'll create a sphere. Right here's my my UV sphere, right? Different kinds of sphere in Blender. I'm going to kind of zoom in here. And my sphere, I can choose different segments and rings. I'm going to make it so that's very smooth. So I'm going to choose my rings to be 32 rings by 32 segments, so a little bit smoother. And I'm also going to choose on the left here this smooth shading option, right, on the side, and this transform toolbar on the side here, right? Yay, it's smooth. Okay, let's add a material because I want to make this a very blue-like world, right? So I'm going to get a material, and I'm going to add a new material. We're going to just call this blue. Why not? And I'm going to change the diffuse quality of the material to more of a bluish color, right? That looks like not so dark, but not so odd. So they're like kind of like this. And my color that I'm using, that's kind of not really the blue that I want. There we go, kind of a sky blue. Is my color, if I look at hexadecimal, is 30AB E7. Again, 30AB E7 if you want to match up with mine. Gamma corrected, of course. Okay, so that's my sphere, and it's in the three-dimensional plane. What I want to do is I want to create a sphere, another sphere, right, which is going to be smaller than this one. So I'm going to make this bigger. So I'm going to click N, right, press the N button, and change my scale. My scale is 1, 1, 1, 1, and let's make this scale like 10. So a little bit bigger than what it was before. So 10, and you can see how it's going to start changing. 10 and 10. So really big sphere. Massive sphere. And now our field of view right now is actually inside the sphere. So I'm going to back up a little bit. Yay, there's my camera. And I don't have any lights that are into my light is actually inside the sphere too. I want to pull that out in a second, which we're going to do. Here's my lamp. We'll pull this lamp out. Here we go. And I'm going to talk to my camera. And you know what? I'm just going to move my camera out a little bit just manually like this. Okay, there it is. So this is my sphere. Yeah, it's pretty big. I want to parent. I want to create a child object, right, in Blender, right? How do I do that? Anyone know how to do a child object in Blender? I want to add an object, I want to parent it, right, to this object here. There's a couple of steps. Simplest way, again, I'm just going to get rid of this and zoom out a little bit so you can see now this is my big sphere here. I want to make a little sphere, and notice that my cursor is still in the center, so I'm going to press Shift-A, right? And where does my cursor go by default? This is key when we go back to 3JS. Well, it's going to go to, my cursor is going to go to my three-dimensional cursor is in the center right now. And by default, any new objects are going to appear at the center, right? So too, when we do our 3JS. Whenever we do our 3JS, we add a child object. It's going to absorb by default the parents' X, Y, and Z coordinates, as well as the parent's rotation attributes, because now the child object's local geometry is the parent's global geometry. Okay, I want to say that again in a second, all right? Be careful when I say this, because this is what's going to mess you up when you try and do rotations of a child object, right? Okay, cool. So I'm going to add this in. I'm going to add another object, so Shift-A, and we're going to add in a new UV sphere. Where is it? It's inside here in the parent. We're going to take it out. There it is. This is our little moon, right? I'm trying to help you with your assignment, if you can't tell. Let's add a little material for the moon, and we'll make it a little bit gray, but not this gray. So I'm going to kind of go in here, and I want to add a new material. We'll just call kind of a dark gray. So we'll call it dark gray. Dark gray. And if I look at my diffuse, notice that it's white, but it looks kind of gray. And the reason for that is because how bright it is. I'm going to pull that even, lower into my spectrum here, which is going to darken my sphere. And if you want to get exactly what I have, if I click the diffuse quality, it's 888888. Okay, that's the hexadecimal values. Okay, so a gray kind of sphere, right? Very gray, dark gray, in fact. A couple things that didn't change is the specularity of the different objects. What specularity stand for again? What's specularity? Shiny or reflective. Reflectivity. So when I say specularity, it's the reflectivity of an object. That's another way of saying reflectivity or shininess, the metallic look and feel of an object, what it has. It can be metallic, more metallic as the more specular it is. All right, so I've got my moon, and I want to see the view from here. So I'm going to change my view. So I'm going to go View, and I'm going to click Align View and I'm going to say align active camera to view, which is Control Alt Numpad 0. When I do that, you can see that this is all I see. I'm going to pull out. And the way I'm going to do that is I'm going to press the N key, right? And I'm going to click down where it says lock camera to view. And I'm going to pull out here with Blender until I see both objects, right? And I'm going to just press the Shift key and just kind of pan to the right there so I can center my camera around my view. Notice that the light is in the scene. I'm just going to pull it to the side here. This is my point lamp, right? I'm going to leave it up here. So we get a little bit of lighting, right? It's not the right lamp for the scene, but it's a lamp for us so we can see what our objects. And now I'm going to take away the lock camera to view feature, right? And just so I can see what it looks like, I'm going to zoom that in so I can see what I'm looking at here, right? And take away the N, this numeric transform on the side here. Take that away. And if I want to see more space, I'm going to press the T key to take away this piece as well. So all I see is more of this. This is what your sphere is looking like. Now, let me rename these things, right? So I can see what I'm talking about. This first sphere, I want you to rename it. All right, so let's call this thing planet. And let's name the second sphere moon. Just we have a good example of this stuff. And again, I use Blender not because I want to teach you Blender necessarily, but only because I want to visualize with you really quickly, right, without typing a lot of code. And so we get the concept first and then do it in 3JS. Okay, that's why I'm doing this multi-stage process, right? Okay, so the question I have for you guys now, and girls, right, is do I have a parent-child relationship at this point between my sphere, my planet, and my moon? No. All right, so in Blender, and if I was to just escape, I'm just going to go back to kind of my regular mode, right? So here's my regular look and feel of my objects. I'm going to kind of zoom in here so I can see them in three-dimensional space. How do I do that? So if I want to parent my moon to my planet, I've got my moon selected, notice on the right here. And if I right-click, shift right-click my planet, shift right-click, right? I have two objects selected. I've got a red selection around my moon, and I have an orange selection around my planet, right? Okay, let's if I do that, try that again. So right-click first my moon, then shift right-click my planet, and then what I want to do is I want to create a parent-child relationship. So if I go to Object down here on the menu, right, and if I look at my Object menu, there's some options I have here. Join, is that what I want to do? That becomes one object. That's not what I want. But there's another object, parent, over here, which is parent object, right? Parent object. So again, there's other options for parent, right? But we're going to say parent object. So Control P is the shortcut. And it's asked you, set parent to what? Set parent to object. If I click this, notice that the moon on the hierarchy here, or the outliner, disappears, and you have only the planet, and underneath the planet, this is a good representation here, you have a moon, right? So the moon is said to be parented to the planet, right? So it's a child object of the planet object. So too does that we work things in 3JS. So again, the process is first you click on the thing you want to be as a child object in Blender. You right-click onto it. And then you shift right-click the object you want to be its parent, right? And then you press Control P. Let me undo this so I can show you the process again one more time. So now we'll do this again. So I'm going to just clear all the highlighting. I'm going to right-click here on the moon and shift right-click on the planet and Control P, which gives you a little menu that says, what do you want to parent to? Object, vertex. This is it's interesting that it asked me to do a vertex. There's a reason for this. Does anyone know the reason why I would want to parent to the vertex as opposed to parent to the actual object? There's a reason for this. Yeah, you can do the vertex. Yes, what do you think it is?
So I would have the rotation of the moon on the parent object. We have it on the point.
Lock the camera on the child object.
Well, let's try this out. Let's see what happens. So if I'm going to go object, take a look, in fact, what you get. If you can't see it, there's a little line here. There's a line that you can see that is drawn between the child object, which is the moon, and the parent object in Blender, which is the planet, right? So parent-child relationship. What we're really doing in 3JS is we're using the add method, just like we do on the scene. The scene is just a 3D container, right? the scene object in 3JS, right? The scene object. So now I have another object. It's of type object 3D, which is that's the superclass of all objects in 3JS, right? And what I'm saying here is I'm saying, take this object and add another object to it. In this way, I'm parenting my child object, right? So, or I'm creating a parent-child relationship is maybe the easiest way to understand that. Okay, cool. So what I mean by this is if I rotate now, if I right-click on this thing, and if I click rotate R, if I press the R button, and I rotate this thing, notice how the planet, the moon rotates as well. So what's happening here is the planet's rotating, around itself. Notice the planet's rotating around itself, around its center, and I can modulate the rotation because right now I just pressed R. If I want to rotate it across the Z-axis, which is the top, if you think about the top of the planet, so I click the Z button here. Notice that it gives me a constraint, and I can see that the moon now, as I rotate, will rotate around the planet just like it would be. As I rotate my planet, so too does the moon rotate, because the moon is parented to my planet. I want to also make a point of this. When you're rotating the planet, the object, what else are you rotating? Think about all the things you're rotating when you're actually rotating the planet. You're rotating the mesh, but you're also rotating its center, which is the main problem people have when they do things like parent-child relationships. The example would be if I parent my camera, right, to the planet, and I rotate the planet, my camera too will rotate in all kinds of weird ways, right? That would be really bad. And you can do that. I can parent any object to any other object. So if I have my camera, which is way over here, and I want to parent it to now my planet, I clicked my camera, right-clicked, I shift right-click to the actual planetoid here, right? And I press Control P, and it's going to say to the object, yay! And then I'm going to just use this idea for us to do this. Notice that this is the perspective that I have. And now let's rotate my planet, right? In camera perspective mode. Let's see what happens in the camera if I do this, right? So I'm going to click R for rotate, and rotate everything, and then kind of stop it around the Z axis. And whoa, where's my moon? Where is my moon? I don't see my moon at all. How come? Well, that's because take a look at my three-dimensional cursor. My camera is moving around along with the planet too. I'm never going to see my moon. Not this way. Let's press escape, right? And again, let me just point this out again. So I'll go to numeric transform and just lock camera to view so I can see my moon. I'm just going to pull out just a little bit here so I can see if I can get my moon. Notice my light just disappears, but for the life of me, I can't see anything. I can't see my moon. And guess what happens? As I'm zooming my camera out, my planet also zooms. My planet's moving because as I'm changing my camera position, it's linked. They're both linked. And notice how it is. In the outline, here's my planet, here's my camera, here's my moon, right? You can have a camera or another object, even a light, as a child to another object. Okay, knowing this, so we're going to leave this little example behind for a second, right? But let me just undo a couple of things, right? So first I'm going to take away this thing here, and then I'm going to just undo some of these changes that I make. I'm going to take my camera out of here, right? And I'm also going to undo the lock camera to view for a second. So I'm going to leave my camera where it was, right? So there's my camera. And I'm going to escape from this view, going back to this view here so I can see my moon. Here's my moon. My moon is right here, and it's parented to, or it's a child object of my planet, right? Here's my planet. And I've rotated it around, and I want to get this view and all this kind of stuff, right? How do we do animation in Blender? Anybody remember how to do this? People, we did it before in other classes with me, but I want to do an animation, right? And the animation that I want to do is every frame. I want to simulate what it's going to be like in 3JS. How would I accomplish this in Blender, right? Well, in Blender, for those people who don't know, because I haven't taught you this here in this class, underneath here, you have another little window, and this is really the animation window. Notice that it has a bunch of divisions that we can see here. One of the divisions you notice is, or down here, there's a couple of other options here. One is start and end. These are the start and end frames. If I want to simulate what I'm doing in my game world, right, I can change the number of frames down here to 60. Let's change the number where it says start and end. Let's change the end to 60. Okay, now we have less frames. Okay, and actually I can zoom in here too. If I just zoom in, as an example, I can zoom into this area here just as I normally would be able to zoom in if I wanted to, right? So right now I'm kind of zoomed in, and as I move my thing around here, notice how, if you notice, that the frame number is listed on the bottom left corner of the viewport, right? So again, I have frame number 0. I want to have frame number 4, and so on. If I want to make this move around, then I need to set up a couple of things. I need to set up something called a keyframe, right? Which is a snapshot of the object in 3-dimensional space, and I can look at different parts of my object, right? When I create a keyframe, snapshot, I can snapshot what are the 3 things I can snapshot in an object. It's not vertices, faces, and edges. 3 things I can snapshot. Actually, there's more. No, not really. Yes, kind of, but really the main 3 things are position, right? So location, right? Rotation and scale. Those are the 3 things I can create a snapshot of, and it'll record, and among other things. It records a lot of other things too. But those are the main 3 things it records, right? So here in my transform, you can see location, rotation, and here's my scale right here. This is the exact same stuff that I see in other gaming game engines, like, for example, Unity, Unreal, maybe even in Lumberyard. Who knows? That new one that's just come out from Amazon. We'll see, right? As we download it and install this stuff, right? But at the end of the day, we can create a snapshot called a keyframe, right? That we can kind of put into our view. And then when we play the animation, right? When we play the animation, all it's going to do is interpolate. It's going to create a motion sequence between. By the way, you can modify this how the speed between these the keyframes and so on. It's going to almost create in-betweens, a lot of frames between. It's going to draw all the frames in between for you. Render all these frames between one keyframe and another. So if I start off with an initial keyframe, right? Let's say at frame 1, which is my initial position, and if I create another keyframe at frame 60, right, which is my final position. An example of this would be if I rotate the ring 360 degrees in 60 frames, right, it's going to continue to rotate. I'm not going to rotate my moon here. All I'm going to do is rotate my planet across the z-axis, right, from frame 1 to frame 60. And then it's going to go back. Now you're going to see some of this weird stuff go on. So we'll check it out. So first I'm going to move my playhead. This is my playhead. I'm going to move it all the way back to 0 or 1. And then, by the way, you can actually set it. The playhead can be set manually down here. We'll bring this up so you can see it. Down here, there's an actual, you can set the playhead to wherever you want. Right now, it's set to 1. If I want to set it to 10, I can just type 10, and it'll move the playhead for me, right? So I want to move the playhead back to 1. And I want to create a keyframe here with my animation, right? How do I do that? How do I create a keyframe? Well, let's go into frame, right? And if I set the start frame and end frame, I can do that here. It also says auto keyframe mode. That's dangerous. Be careful about that one, right? How about object, right? If I go to object, can I create a keyframe, right, with my object? So I've got my object kind of in there, and I want to create a keyframe. Can I do that with here? Here's animation, insert keyframe with the I button, right? That's what I would do, right? All right, so let's do that. So let's remember my location, rotation, and scale for this thing. It's all, one thing is that the rotation for Z, let's reset that back down to 0. So we have, everything is reset. There's my Z rotation, right? My scale is 10, 10, 10, right? And I want to create a keyframe. I'm going to press the I button. And it's going to ask me, what do you want a keyframe? When I press the I button. And I can choose either location or rotation or scale or location, rotation, or location and scale, or all of them, location, rotation, and scale. I want this one, location, rotation, and scale. Cool. Notice how these ones in Blender become yellow, right? That means we've recorded our first keyframe. It's in keyframe 1 or frame 1, and the location, rotation, and scale, right, is all recorded. Now, you'd be forgiven to think that I can go to frame 60, and we'll try this out first. Let's try this out. So I'm going to go to frame 60. I'm going to move this out. And by the way, you can scroll down here, or I can just type the number, 60, right? There I am. And notice that my frame, my location, rotation, and scale is all the same. But I want to change this now, right? So I want to change the rotation, location, and scale for this one. And I'm going to physically do that. I'm going to do it numerically for now. I'm going to rotate across the Z-axis, right? Across the Z, how many degrees am I going to rotate? Really? 360 is like 1, right? So I could do 359, right? And that's the right thing to do. If I go 359 degrees, it rotates. It's almost exactly the same as where it started, but going back to 0 is what's going to happen, right, across this sequence. Okay, cool. So 359 degrees. I need to make another keyframe, right? So I'm going to press I, and I'm going to choose location, rotation, and scale, right? Here he is. And now you can see that my keyframe, there's 2 keyframes from one and the other. And if I press play down here, so if I press the play button, here's down here, it should rotate now all the way around continuously. Notice how it stops for a second. Why does it do that? Well, there's just the way I've written my keyframes, right? Because it goes to number 60, and it slows down to this. But it's a good thing to do, and I'll show you why it's doing that. So there's my animation. So it's kind of a simulation, right? Let's change that. If I want to change my keyframe, I can stop it from playing, right? And again, this is a way we can simulate stuff in Blender as well and test things out just to make sure that they're viable. They can be done, right? If they can be done in Blender, chances are they can be done in 3JS, right? If they can't be done in Blender, if you don't know how, it's probably going to be difficult to do in 3JS as well, all right? Just letting you know. All right, so let's go back. Let's put a playhead back to the back here, or right to frame 60. And notice how we go to frame 60 and it goes right back to 359. Let's change this value. So I'm going to change this to 360, right? And we're going to record another keyframe. So I'm going to press I, just like you suggested, and location, rotation, and scale. All right, so 360. Let's see what effect that has if I press the play button now. So press play and then zoom, and it stops again. Notice how it does that every time. It just stops. And it kind of goes back, right? It repeats, right, around these 60 frames. That's what it does. Okay. Let's try something else, just to give you an idea. I want to show you this because in your mind, I want you to picture it. Okay, that's the reason why I'm telling you. So let's stop the playhead. And let's go back to frame, instead of frame 60, I want to make it I want to keep frame 60 for now, and move it to that frame by moving it there. There it is. Here's my playhead. I want to clear my keyframe, right? So if I go to Object and I go to Animation, I want to clear my keyframes here, right? There it is. My keyframe should be cleared. Well, it's not. There it is, right? So again, Object, Animation, right? And if I go Delete Keyframe is what I want, right? Delete it. Yes, it's gone. There's no more keyframe. I want to get rid of frame 60. So I want to move back. I want to say my end is frame 59, right? There's 59, right? And I want to move this back, my keyframe back to frame 59. So I'm just going to go back there. So there's 59. And I want to go to 359 degrees, right? With my Z. So instead of 350, go 359. There we go. And now I want to save my keyframe. What does this do? 1 frame difference. So from frame 1 to frame 59, right? Not frame 60. Let's see what that does. Insert my keyframe, location, rotation, and scale. Good. And now let's run the sequence, right? And there's still a bit of a slowdown, right? Don't you see that? Part of it is the way that Blender is doing this. It's almost like this. It's an animation arc, right? And what it's creating is it's not a linear arc for Blender. What's happening is in the background, it's slowing down, it's easing into that particular thing, and then easing out again, right? And that's why it's showing you the way it is. But this is a good way of understanding what's happening here. How about if I want to modify its location? Well, I can keep track of all those things, location, rotation, and scale, right? Well, this is what you're really doing with your little game loop. Your game loop, every 60 frames, you can rotate something like this over and over. Notice how my planetoid here is rotating, but my moon is staying in the exact same location. It's not rotating. It's just rotating around my planet, okay? Okay, be aware of this. We'll look back at this later on. Okay, so I want to do the same thing in Blender, or in code that I did with Blender. So let's pull up our last piece of code, just to, can I pull this up? I'm going to pull up some stuff, because I want to do the exact same thing, and I want you guys to help me out, because it's a good learning thing for you guys. So when I go to GitHub, and we have this last thing that we have, right? So let's pull up GitHub. I'm going to go to Centennial. And the last thing we did was we did this little lab 3, okay? Lab 3. Let's pull that up as a way to start off our project. So I'm going to go to lab 3. And I want to download this as our starter. Okay, this is going to be our starter. I want to rename this thing. Again, you can start any of these as starter, but this one has our little gulp automation, right? And I want you to pull it down, all right? And I want you to change the name, and we're going to use this one to create our objects. Okay, so let's do that. So how do I do it? I'm going to download the zip file, right? That's what I would normally do. Or I can clone to my desktop or wherever I want it. I can clone by using the clone command, right? Git clone, and the URI. All right, I already have this thing on my computer here, right? So if I go to COMP392, I have something called Lab 3. I'm just going to copy it and paste it, right? Which would be like duplicate for you guys. There. I'm going to rename this thing. You've seen me do this before, but I'll do it again. And I'm going to call this thing lesson 5, right? Is what I'm going to make it. But it's not really lesson 5, is it? In the background, this isn't lesson 5. This is still lab 3. So I got to kill my Git repository. So I'm going to go open in terminal. And just as a prep, here's my terminal. Let's try this again. Yours is command prompt. I'm going to kill my Git repository. So I'm going to say something like this, rm minus rf, and I'm going to say .git, which is going to clear up my repository in COMP392 lesson 5. That's what this is going to be. And I want to include everything right now. So I'm going to say git add, git init first, git init. That's my first thing. So I initialize my repository. And I have like 99 plus changes over here, right, on the left, as you see before. Let's change some stuff here to make it so that it's lesson 5. So right now it just says COMP392 lab 3. Let's just say COMP392 lesson 5, so we know it's the difference. We'll save this one. And we'll do the same thing for our README file, COMP392 lesson 5. Take this here and put it over here. There we go. And let's do the same thing with our package.json file, right? So that's lesson 5. We're going to use a package.json file if we're going to make use of gulp automation, right? That's the only reason why I would need a package.json file in our example, lesson 5. And you know what? This is going to be, instead of this COMP392, I'm going to call it lesson 5. Just take this. That's going to be the new Git repository I'm going to make. I'm going to call it exactly that. It's just this. And over here, you can see what I'm doing here. I'm just renaming stuff so that everything is going to be aligned with my new project. Right, so this is lesson 5 and lesson 5. There we go. From lesson 5, I'll just type that in. Lesson 5. Okay. Okay, so I think I've covered most of it. Let's just file save all. And if I didn't, I'll grab it later. Just renamed everything. The project has just been renamed. That's all. Okay, cool. Let us, after I've done this piece, after I've got my project renamed, and I saved everything, let's go back into command line and go git add dot, which is going to add everything to the staging area. And then from there, I know. And then go git commit -m. We'll say initial commit. Yeah, we've caught you sleeping. Sorry, buddy. And then, and I'm sorry, I'm trying to show you this stuff. So you see, you've seen this a bunch of times because, you know, well, guess what? On an exam, right, what's going to happen is I'm going to give you something. I'm going to say, hey, take this, you know, this example exam, midterm exam, and make it your own. Call it something else. You know, go through all these steps, right? And it's there's going to be some points awarded for you to do that because I've been showing you every single time, right? All right. So this is part of this. Why I'm showing you. So please, I know it can be something. If you've seen before, it can be rather dry. I apologize. Let's get through it. Okay, cool. So this is one thing. And then on GitHub, what would I do next? I want to do my workflow. I want to create my workflow for my new thing. Come on, guys. I'm going to ask you some questions. What would I do next? So I've created my local repository. What's the next step? My remote repository on GitHub. So let's do that. So let's go into here, and I'm going to go to Centennial College, right? And I'm going to create my remote repository here, and I'm going to name it correctly, COMP392 lesson 5, and click create repository. And when I do that, it's going to give me the script that I need. These last 2 lines, I'm just going to copy them. So that's all I need, and go back over here and paste and press enter, and it's going to send everything I have right now up to GitHub. And the next step is going to be me putting it on Azure immediately by going to portal.azure.com, just in case you guys into the workflow, logging in, right? I'm just doing it a little faster than I normally do, right? As long as Azure allows me to. And I'm going to create a new workspace for my Azure stuff. You guys have done this before. You can do it on your own now. Create my web app. Call this COMP392 Winter 2016 to give you guys some space. Lesson 5. There we go. And press create. I'm going to create my repository, my web space up online somewhere. When it deploys, I'm going to create my auto deployment workflow, and then I'm good to go. But I still got some stuff to do, right? I want to at least build it one time, right? I want to build it one time, and I want to do that with gulp. What's the command that I told you last time that'll just build everything, right? I'm going to target my default task with gulp. So all I have to do is gulp, right? If I build a default task, boom, it launches a gulp. The gulp command itself will launch everything else. Let's check this out, as long as I've linked it together. And here's continuous deployment. And I'm going to click my source, and I'm going to click GitHub. You can choose other sources. And once it connects to me, I'm going to choose the proper account, which is going to be Centennial. And then from there, I'm going to choose my project, which is this new one, lesson 5, and click OK. And now it's going to do this continuous deployment dance where it grabs stuff from GitHub and throws it into Azure. And then we're fully we're done for this piece. We've done our whole deployment, all right, from local repository through the remote onto our cloud host provider, Azure. Okay. Now I'm using Azure, but you can do the same steps with other cloud service providers like Heroku, as an example, as an alternate, or others. I'll wait till this is done. But I'm pretty sure if I just click on this now, even if it's not done, it's going to get there, and it's going to show me the web app has been successfully created. I was too fast, right? And if I refresh, and then eventually, one day, if everything goes well, it's going to show me my app, right? There it is. Yay. Okay, cool. So I've got my stuff, and I've got my remote app, and I want to try it locally. Again, just as a refresher, I'm going to clear my screen here. And for me to check this out, I want to just choose gulp. And when I do that, if everything goes well, it'll launch a local version of my gulp repository right here. This is gulp locally. Yay, and I've got my stuff. Okay, cool. I want to make, and here's what I want to challenge you to do within these next few minutes. I want you to make a child object of the cube, another little cube, right, that I want you to make it so that it is, let's say, 1/10 the size. All right, here's the thing. I'm going to stop it at the break. I want you to try this out, and we'll come back, right? And I want you to create a child object of the cube. That's all I want you to do. Nothing else. Just make a child object of this cube. That basically just, you know, and make it green if you want. Make it any color you like. But another little cube, 1/10 of the size. That's all I want you to do. Make a child object of this cube. Okay? Go. And I'll come back at the break, and we'll show you the results.